Welcome to this comprehensive guide on CoroutineContext in Kotlin. In this video, you'll master how to configure and manage state using CoroutineContext, one of the most fundamental concepts in Kotlin Coroutines. Understanding CoroutineContext is essential for building robust and efficient concurrent applications. Let's dive in and explore how CoroutineContext shapes the behavior of your coroutines. CoroutineContext is a set of elements that define the behavior and configuration of a coroutine. Think of it as an immutable index set of element instances, where each element has a unique key. It works similarly to a map data structure, but with enhanced composability features that make it perfect for managing coroutine configuration. This index structure allows you to store and retrieve different configuration elements efficiently, making it the backbone of coroutine behavior management. CoroutineContext consists of 4 core elements. First, the job controls the lifecycle and cancellation of a coroutine. Second, coroutine dispatcher determines which thread the coroutine executes on. Third, coroutine name identifies the coroutine for debugging purposes. And fourth, coroutine exception handler handles any uncaught exceptions that occur during coroutine execution. Each of these elements plays a crucial role in defining how your coroutine behaves and interacts with the system. Creating a coroutine context is straightforward using the plus operator. You can combine multiple elements together to build a complete context. For example, you can combine dispatchers.io with coroutine name passing a string like my coroutine and add a supervisor job. Once you've created your context, you can use it to create a coroutine scope by passing the context to the coroutine scope constructor. Then, when you launch a coroutine within that scope, it will inherit all the elements from the combined context. Inside a coroutine, you can access the current context using the CoroutineContext property. To retrieve specific elements, use square bracket notation with the element's type as the key. For example, to get the job, use CoroutineContext square bracket job. Similarly, you can access the dispatcher with CoroutineContext square bracket coroutine dispatcher. For the coroutine name, use CoroutineContext square bracket coroutine name, then access the name property. This indexed access pattern makes it easy to retrieve any context element you need during coroutine execution. One of the powerful features of CoroutineContext is inheritance. Child coroutines automatically inherit the context from their parent coroutine. For instance, if you launch a coroutine with dispatchers.main, any child coroutines launched within it will also run on the main dispatcher by default. This inheritance mechanism ensures consistency across your coroutine hierarchy and reduces the need to repeatedly specify the same context elements, making your code cleaner and more maintainable. While child coroutines inherit their parent's context, you can override specific elements when needed. Using the plus operator, you can specify a different context when launching a child coroutine. For example, if a parent runs on dispatchers.main, you can launch a child with dispatchers.io to override just the dispatcher element. The child will inherit all other context elements from the parent, but execute on the IO dispatcher instead. This selective overriding gives you fine-grained control over coroutine behavior. Kotlin allows you to create custom context elements for domain-specific needs. To create a custom element, define a data class that extends abstract coroutine context element, passing the companion object key to the constructor. The companion object must implement CoroutineContext.key with the element type. Once defined, you can combine your custom element with other context elements using the plus operator and access it later using the square bracket syntax. This extensibility makes CoroutineContext incredibly flexible for storing application-specific state. The withContext function allows you to switch context temporarily for a specific block of code. It's a suspend function that takes a coroutine context as its parameter. For example, you can create a suspend function that uses withContext with dispatchers.io to perform database operations on the IO dispatcher. When the withContext block completes, execution automatically returns to the original context. This makes withContext perfect for temporarily switching to a different dispatcher for specific operations, while maintaining the overall coroutine flow. Let's wrap up with some best practices. First, define your context at the coroutine scope level for consistency across all coroutines in that scope. Second, always use coroutine name for debugging and logging. It makes troubleshooting much easier. Third, leverage withContext for temporary context switches rather than launching new coroutines unnecessarily. And finally, create custom context elements for domain-specific state that needs to flow through your coroutine hierarchy. Following these practices will help you write cleaner, more maintainable coroutine code.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.